Marco Codes! Today we're going to talk about Maven nice and easy. If you're programming in Java or any of the other popular JVM languages such as Kotlin, you want to use a build tool like Maven. Maven makes it easy to download third-party dependencies for your project. It also gives you project structure through a set of conventions. And it allows you to have plugins to, for example, quality check your code or deploy your code later on. Sounds like fun? So let's check it out. Surprisingly, I found a project on GitHub which is called Maven Tutorial. You can find its URL in the references section. I know it's a Maven project because it has a Pom.xml file and a source folder, and we're going to check those out in a second. But first of all, I want you to get the URL and clone the project in a directory of your liking. Now step inside the folder, have a look at the contents, and you can see, well, the Pom.xml file is there, the source folder is there, all good to go. The issue is we don't have Maven installed, and we need to start with the boring stuff, getting Maven up and running on your machine to do anything with that project. Now I'm going to show you a couple of simple ways to install Maven on your machine. If you're using Windows and are using Choco as the package manager, simply type Choco install Maven. If you're on macOS and you have Brew installed, Brew install Maven. If you're on Linux like Ubuntu, apt install Maven. If you're on any other distribution, just use your favorite package manager, install Maven. I'm going to show you the Pom.xml version of installing Maven because it's actually quite simple. What I want you to do for that is browser, search for download Maven, pick the download Apache Maven link, scroll down a tiny bit, choose either the zip file or the tar.gz file. I'm going to go with the zip file here on Windows, download it, and extract it into any folder you like. In my case, that would be C user screencast code. Doesn't matter what folder. Hit extract. There we go, Apache Maven 385. One last thing to do, you need to add the Maven executable from inside the bin folder to your path variable. In the references, you'll find commands on how to do that for every operating system on the command line. I'm going to show you the visual way of doing that here in Windows for now. Simple, just enter environment variables for my account. Have a look at your path, edit, new variable, paste in the path to your directory /bin. Hit OK, OK, new terminal window, Maven-V. Here we go, we have a working Maven version 385. The Maven home should point to wherever you extracted Maven to, and then you see also that it uses Java 17, which is installed on my PC. That's how simple it is to install Maven if you're not using a package manager. Now, one more thing. It's a bit stupid that you have to install Maven to basically work with your project to build it. So let's go back inside your code Maven tutorial folder. And what you will see here is that there is really only just the Pom.xml file and the source file. If you're used to working with Spring Boot, for example, you might be also used to some other files called Maven W, which stand for Maven Wrapper. Let me show you what the Maven Wrapper is. If you have a project which doesn't include the Maven W files, and you have Maven installed, there's kind of a chicken and egg problem, you can install the wrapper by calling Maven Wrapper :wrapper. It's going to run for a second, and what it's going to do is, when you have a look at the directory again, you can see now you have two files, Maven W command. This is the Maven wrapper for Windows with a .cmd suffix, postfix. Maven W is for Linux, macOS. What that means, if you now check out the project, if you now clone it from GitHub on a different PC, that PC doesn't have to have Maven installed. Instead of going like Maven-, you can now use Maven Wrapper -v. And that you can see the Maven home now is different. It shows you, well, see screencast.m2 wrapper. It's an embedded Maven version basically that comes with your project. So as soon as you have the Maven wrapper installed, you actually don't need to have Maven installed on your machine anymore. Just for the initial wrapper creation, someone needs to have it. Right, now let's check out if our project is actually a valid Maven project for that. If you have Maven installed globally, just go with MVN. Otherwise, use the wrapper and do a Maven validate. What Maven validate does is it has a look at your project at the Pom.xml file and just checks if indeed it is a valid Maven project or if it has a broken XML file, whatever. But we're getting a build success. That means we're all set to go to have a deeper look at what our Maven project actually consists of. For that, I actually want you to use an IDE. Choose whatever IDE you like, and if you don't want to use an IDE, then just follow along with your text editor, but using an IDE will make a couple of things much simpler. I'm going to use IntelliJ IDEA, the community edition. It's free, you can simply download it on the JetBrains website, and then just open it up and come back here. IntelliJ, here we go. Let's open up the project. It's going to be my Maven tutorial. I'm just going to highlight the folder, click OK. I'm going to trust the project. Yes, it is my own project. And then I'm going to wait a second for IntelliJ to basically import the project. And you can see down here in the lower right corner, there's something happening. You see that there's stuff being indexed, dependencies are being downloaded. The Maven Wrapper was successfully installed, meaning that IntelliJ will also use the Maven Wrapper to build your project, which is quite cool. And now we're going to have a first look at what a Maven project actually looks like. As I mentioned early on, you have a Pom.xml file which defines your project. We're going to have a look at that in a second. Also a source folder. Inside that source folder is where you'll see my source code lives, the production source code, and also my tests live. We're going to have a look at that again in a second, but now let's check out the Pom.xml file, which is the most important piece for now. Pom.xml file, they all look somewhat similar. What you'll find is at the top, you'll find there's a group ID, an artifact ID, and a version specified. Essentially, group ID, artifact ID uniquely identify your projects among all the projects in the world. And what you usually do is you take the reverse of your domain name, like com.jetbrains if you're working for JetBrains or a different company. And then because I might have several projects, I'm just going to choose com.jetbrains Marco as my own group ID. Artifact ID is my project ID. It's a Maven tutorial, so it's called Maven tutorial. That's it. Version 1.0 snapshot is the default version. Snapshot means it's a work in progress. It's not a release version like 1.0 whatever, and it can change all the time. Now, what else can you find inside a Pom.xml file? You can find properties. There's some properties, like for example, Maven compiler source and target, which configure something inside Maven. These two tags are a rather convoluted way of saying, Maven, my project should be built with Java 11 for Java 11. Then there's some properties you can define yourself, like JUnit version that I defined here, and I'm going to show you where I'm using that inside my Pom.xml file later on. Then you have a build section. The build section allows you to specify plugins. As I mentioned before, Maven projects can have plugins. And those two plugins have something to do with testing later on, with test output, so you can actually see, please Maven run my MP3 util test and show me the test output, how many tests methods you executed, if there were any errors and whatnot. But there can be any sort of plugin for deployment, for anything you'd like. And then the nitty-gritty dependencies. Now, here's the deal. My project is actually an MP3 util. I don't even know if you work with MP3s anymore. You have an MP3 file, and usually it has metadata, like what is the song's title, who recorded the song, what year did the song come out, and all that sort of stuff. And I don't know how to work with MP3 files, how to read the headers and whatever, so I want to use a library. I found a library, it's called MP3 Magic, right? And you can see I specified a dependency that my project has a dependency on that library in the Pom.xml file. For that, I need the library's group ID, com.mpatrick, and I need the project ID, the /artifact ID, and the specific version I want. And that is enough. This tag here is enough to tell Maven, hey, please download this dependency for me and make it available inside my project. That's pretty nifty. There's also some other dependencies in here. You can see, again, there are 3 dependencies that have something to do with JUnit. JUnit used for running the tests. There's just 2 differences to above. First of all, down here you can see I'm not specifying the version here hard-coded. I'm just saying these 2 libraries should basically just take whatever I specified in my properties up here, 5.8.2. That was the reason why I specified a property I can reuse inside my Pom.xml file. But when I will go down again, there's one more thing, that dependencies can have scopes. And what scopes mean, actually rather simple. So if you say dependency MP3 AGIC, then the scope is hidden, but it's set to compile. Compile means your project needs the dependency when you compile it, when you run tests, when you deploy it later on. Then there's a scope called test. Test means you only need the dependency for running your tests. So this single class down here on the left side. You don't need it later on when you deploy your project. You want just to get rid of all these libraries. You don't want to add another 50 megabytes or whatever of test libraries to your final executable, whatever that is. Then there's a couple of other scopes like provide and whatnot, but you'll find links in the references of what these scopes mean. For the beginning, compile and test are the two scopes you will basically work with. Now the next question is, Marco, how did you actually find out about com.mpatrick that this is the MP3 library you want to be using? I'm going to tell you a little secret. What I did is I opened up a browser, new tab, I put in Java MP3 library, right? Look at what the first search result is. mpatrick, a Java library for reading MP3 files. I had a look at that GitHub repository. Actually, do you see it's a Pom.xml? It has a Pom.xml file source file. It's also a Maven project, right? I had a look through the description. It said I can do anything I ever want to do with MP3 libraries. And handily enough, it already gave me the XML tag. I can just copy, right? Go back to my project. I can replace this tag here. And obviously it didn't change because it's the same tag. So that's what I did. I had a look at online on Google, what is a sensible MP3 library? I had a look at the GitHub site of that project, and I just copied down the dependency block. It's the same thing you're going to do essentially with almost every project, unless you already know what you're looking for. Then you have a couple of different choices. For example, you could go back to your browser. Put in search.maven.org, link in the references. And then if you already know what you're looking for, you could have just put in, hey, mpatrick, and you can see, well, there's just one library which has a group ID com.mpatrick. You can click it, you can see the latest version is there, right? Even have a look at the version history, 9.0, 9.1, that sort of stuff. And when you open up a specific version, here on the right, you see this is the tag you want to download for Maven. Here's also the tags for other build tools like Gradle, Kotlin, DSL, Scala, Apache Ivy, whatever. But you just want to download this one here, 9.0. Then I would go back, I would replace my dependency here. I would make sure in IDEs like IntelliJ, they are not reloading your dependencies automatically. Here on the upper right corner, you have this icon, load Maven changes or Control-Shift-O. You just click it, and now actually IntelliJ processes your Pom.xml file and downloads the new dependency. How can I see I have the new dependency downloaded? Simple, you click external libraries here on the left, and there you can see from Maven there's a dependency in your project, com.mpatrick mp3 agic 0.9.0. And if I want to, I can go back to 1 and hit the reload button. And in a second, you'll see it says, here is the new version of your dependency. That is pretty cool. Last trick, instead of having to go to a website, if you're using something like IntelliJ, simply hit Alt-Enter, dependency, and here you can simply, search for mp3 agic, right? It gives you everything inside the IDE. You don't even have to go to your browser. You can just click a specific version, and now it gets inserted automatically. But this is a bit nonsensical. I don't want to insert an additional version, so I'm just going to delete it here again. So altogether, plenty of ways to add dependencies to your project. All right, now let's finally do something with all that information. First of all, just a quick look at what our project actually does. There's just one tiny MP3 util class. It has one method, getArtist. You put in a path of an MP3 file, and it tells you what is the artist of the album, right? Makes sense. Then you have an MP3 util test class. It has one method. It says getArtist should be Marco. Basically what it does is it tries to get the my MP3 file, the one inside your project folder, and says the artist should be Marco, and that's it. If you run it, you'll see it scream because the metadata on the MP3 file is correct. And for whatever reason, Marco is spelled like that on that MP3. Now, let actually not the IDE compile the project, but let's tell Maven how to compile your MP3 util class, and also let Maven run the tests. And for that, what you want to do is you want to open up a new terminal window. I'm just going to do it from inside IntelliJ here, but just open any terminal you like. Let's start with the first command, Maven clean, something that people like to do. Maven clean, and now IntelliJ actually tells you, why don't you let me run it inside the IDE? I got that, I understand that, but I want to do the Pom.xml version of Maven. So Maven clean, what does Maven clean do? If you, for example, saw here on the left, all your sources and your tests, they live respectively source main Java. There's your production sources and your test classes under source, test Java, and here's your tests. Now what Maven actually does is, it does something whenever it runs commands, it does something and moves them to the so-called target folder. We're going to have a look inside that target folder in a second, but now we're going to do a Maven clean. What does Maven clean do? Maven clean deletes the target folder. That's the only thing it does, delete the target folder. Next thing, Maven compile. What does Maven compile do? Maven compile has a look at source main Java, your packages, every class under source main Java for now, compiles those Java classes, and puts the class files under target classes. Here you can see, here is your class file, the MP3, the compiled Java class. What else do you have? Maven test. Maven test does actually internally already a compile, so it depends on compile. So it's the same as writing Maven compile test, or as you by the way might have guessed, Maven Wrapper compile test. It's all the same now as I have the Maven Wrapper inside my project. Maven W compile test. It will first compile your MP3 util, and then it will have a look inside your source test Java folder. That's the convention, that's the Maven convention, to have those folders. Have a look at all the test classes inside here, MP3 util test, and run them and show you a nice little report. Let's do it. And as you can see, there's a nice little error message here. In PowerShell, if I trust this command, please re-execute it with a dot and a backslash. Well, so I'm going to do that, right? And there's a ton of things that you can actually see here. Let's have a look at the output. So I'm building the Maven tutorial project in Snapshot 1.0 version. Then first of all, the Maven compiler plugin is running, trying to compile my MP3 util Java class. It doesn't have to compile anything because I just compiled it a second ago. Then what the thing also does is it tries to do a test compile. Test compile means that it now has a look at the MP3 util test class, compiles it, and then actually even later on, it runs it with that Surefire plugin you saw earlier on in the Pom.xml file. You can see tests have been run. One test, the test was green. There were no failures, no test classes were skipped, or no test methods were skipped, and everything worked perfectly fine in 3.0 seconds. Right, so we had Maven, clean, compile, test. What comes next? Next comes package. Package actually includes compile and test. So we'll compile your classes, it will test the classes, and then it will take your source code and put it into a jar file that you can send to a friend and run it there. Clean, however, will first of all delete your target folder again, right? So let's do that. And then everything will be redone from scratch. So again, stuff is being compiled now. The output is not being reused from before. Tests are being run. Everything is going to be packaged up. How can I see that stuff has been packaged up? In the target folder, Maven-tutorial, here's my jar file that I can send to a friend. And then the friend can actually reuse whatever my project is doing. He can reuse my MP3 util. Last but not least, Maven compile, test, package. And I'm just writing that because they all depend on each other. So this is the same as writing Maven package, right? The last goal you want to know, and that basically a ton of people are using out in the wild, is Maven install. Or usually they do Maven clean install. So that means, first of all, delete the target folder, rebuild everything from scratch, rerun all the tests, and then do an install. Install does a package, so the jar file gets created. It does one more thing with the jar file. The jar file is being put into your local Maven repository. And that means we have to find out what a Maven repository actually is. For that, let's have a look installing the jar file to C user screencast.m2. So there seems to be a .m2 directory in your home directory. Repository, com JetBrains Marco. So that is my group ID, that is my artifact ID, that is my version, and here is the jar file. So what I'm going to do is I'm going to copy this whole thing here, open up an Explorer window, step inside that folder. Well, that didn't work. It doesn't matter. Repository. I can see actually that inside this repository, inside my Maven repository, all the dependencies that Maven ever has downloaded on my PC, they are basically in here. So let's see, JetBrains, Marco, Maven tutorial. Here is my jar file in version 1.0 If you remember correctly, and Patrick, MP3 Agic, the two different versions are here as well. So everything that Maven ever downloaded is inside your user's home directory .m2 inside the repository folder, split up by group ID, artifact ID, and version. Where does Maven get all the dependencies from? Well, there's one main global Maven repository, and there's actually many more popular ones, and then your company can also have its own Maven repositories. But in theory and also in practice, what happens is that whenever Maven tries to download a dependency, it tries to ask the global repository, please give me the dependency, and then it downloads the stuff, puts it into your M2 home directory, so it can be reused later on. As always, you'll find the link to the Maven repository, to the global Maven repository in the references. A couple more lines on Maven's convention style. As I told you earlier, you have the Pom.xml file, source main folders, Java or Kotlin or whatever have you for the different programming languages. Source test folder, the same thing. And what these folders can also include are additional folders called resources. Inside the resources folder, what you usually find is stuff like your application properties that you might be used from when you're using Spring Boot, whatever. You put all this stuff, all the properties, text files, whatever have you, some resources, images, static stuff, you put them all under source main resources. So the convention is to split up your Java source code or whatever have you from the static text files which are not being compiled and they're just being copied to the final deliverable, to the final executable. The same thing in the source test folder, source test Java, you can simply create a resources folder and put your test specific resources there as well. And this convention is kind of nice because now, whenever you have a look at a Maven project on GitHub, whatever, you know to expect there's a Pom.xml file where you can find all the details, what dependencies, what versions, group IDs, whatever. And the source code is always going to be on the source main for your production code, source test for all your test code. And that makes it very easy to get started with any sort of Maven project or any sort of Gradle and other build tools. They all follow the same convention, essentially. Right, let me quickly open up a more complex Maven project because so far this is a simple library, Maven tutorial, just one Maven module, so-called Maven module with a Pom.xml file, nothing else. I prepared another project for you as well. Let's check it out. Here we go. As you can see, well, the thing is, the only difference now is that our Maven project consists of several submodules, which means we have a so-called simple parent Maven project. It has a Pom.xml file. Let's have a look inside that Pom.xml file. You can see it looks basically similar. It has a group ID, artifact ID, version and whatnot. The packaging is set to Pom because this project here, the parent project itself, doesn't produce a jar file like the project did earlier, so we have to set the packaging to Pom. It's just a Pom.xml file here. And then the project itself consists of a couple of modules. Module simple command, simple model, simple weather, whatever. They correspond to the folders inside your simple parent directory. And these are all the Maven modules your project consists of. Now, when you try to build the parent in a second, what's actually going to happen is the parent is going to build all these modules. Simple. Same thing as before. The parent can have, a build section. It can have a dependency section. And actually the dependencies and whatever, they're being inherited. So the children will all have the dependency JUnit 4.12 in this case, for example. When you look at a specific, let's see, simple model, Pom.xml, let's have a look at one tiny module. You can see essentially what it does is it specifies the parent, simple parent, so what's inside the Pom.xml file here. It doesn't specify a version anymore because that comes from the parent. It specifies a packaging jar file because that model is being combined into a jar file at the end when you build it. And it has its own dependencies. The same with persist, for example. You have a look, again, it just specifies the parent, artifact ID, packaging jar file, blah, 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 a couple of dependencies here. The only thing, by the way, is that persist has a dependency on model. So these modules can have interrelated dependencies. Did that make sense, right? So effectively you're saying here you can only build persist if you build the model module before in version 0.8 snapshot. Actually, you don't have to specify the explicit version. You can just say, as long as they all live in the same project, hey, please, I need a dependency on simple model with the same version that I'm being built in. What a complex sentence. And as always, make sure to refresh your project. And then you can have a look around at the weather module, web app module, command module. They all follow the same thing. So the only thing that now changed as to before is you have one parent Pom.xml file, which specifies all the modules, right? And then in the folders, you have these modules. They all have their own Pom.xml file. They inherit some stuff from the parent Pom, and they can specify their own stuff. And that is essentially multi-module Maven projects. Yay! Maven! That was Maven in a nutshell. We didn't cover a ton of topics, I know, but that was the quickest jumpstart possible into the whole Maven ecosystem. As always, you'll find further links, reading materials, recommendations, whatever, down in the references. Enjoy. Sayonara.